All right, welcome everybody. Tonight is the 2nd of August in Dallas. This is the Dallas Personal Robotics Group Robot Builders Night Virtual. Pat is preventing COVID sharing and cross-contamination since there's been some rumors of that going around. So this is a good virus protection there, Pat. Pleased to see that. Tonight we are going to just go around the table as usual. And let's see. We have in queue so far Ray and Doug D and Michael. And after that, I think it's a free-for-all. So as mentioned, I'm going to step away, but you all just carry on and catch up with you in a little bit. So Ray, have at it. The floor is yours.
Right?
What?
Yeah, Ray, then Doug, then Michael. I'll put that in the chat.
Okay. I've been, working on my platform. This was the two-wheel platform. It's over here. I think you've seen it before. It has an ESP32 on it. One of the Series 8 SparkFun GPS modules, B&O 055, and a little OLED display. And I've just been trying to...
Now, Ray?
Yeah.
You're presenting, but I'm not really seeing any of this. I just see your screen.
Oh, okay. Did you see it when I held the camera up?
I have to admit, I was looking the other way for a minute. I just was pointing out.
Oh, okay.
Ray, I think you have the wrong screen.
We're seeing an infinite regress of OBS.
Okay. Install presenting. I've been working on, this is my two-wheel platform here. If I can get it in view. On the top there is the B&O 055 and the display, and then down below is a RoboClaw 2x60 to drive the motors, which is really overkill, but that's all I had. An ESP32, and one of the Series 8 SparkFun modules. And I was getting really weird results out of, you basically, to guide the platform, you need a distance and an angle or a heading. And then like to the local reference or frame of the robot, you can, tell it how to do that with encoder ticks and, and driving it with the compass basically. So it knows, if it takes a reading, knows what its current GPS coordinates are, and you give it, other GPS coordinates to go to, it can figure out the difference and basically, how far away that is and what angle to steer to or what heading. Anyway, let me go. I'm going to present entire screen, the sharing. Okay, so to try to help me out with that, can you see that Arduino program?
Right.
Okay. Anyway, there was another bearing calculation that you can do. It was different than the one that Dave Anderson recommended, and for some reason it's not working with the Cutie Pie, which is a SAMD 21. I don't know why. It's kind of weird, but this one actually worked versus Dave's. It produces the right bearing. And one of the other things that I did is I took a look at where it is. Okay, bearing angle. So this is my house, and these are 2 points here, A and B. And, I could verify that the angle was being calculated correctly, like through another means, versus my program. And that's what the bearing should be. But using Dave's equation for the azimuth, it was not working for some reason. And I've looked at it. It looks like he's been using the same equation for a long time. And so I'm not really certain why it wasn't working. I know I tried it out just a few minutes ago, and it seems to find the the GPS coordinates. I had 3, like one here, one over here, and then one here. So it just did kind of like a triangle. And it found the first 2. Something weird happens here. It sits there in circles, so it actually didn't find the 3rd one. So, because it just sits there in circles. And I'm assuming that it gets outside of the, there's like what, I think 2.5 meters of ambiguity. Readings could come any place in there. They can be random. So it's not super reliability without RTK. So the other thing that I did is, with the QtPy and the other formula, I put together, more or less like a handheld GPS unit. And that's the code to run it. And I had it so I had 3 different latitude and longitudes that I could look for, and basically just see what I was interested in is the basically the degrees azimuth and and the distance, the meters distance. And the meters distance seemed spot on. It was right. But like I said, the other one, using Dave's older calculations here, it didn't work right. These had to be used to make it, produce the right bearings. So that is just, I'm gonna stop sharing for a second. Oh, okay, gotta get back to the right screen. There we go. And I already pulled it over here. So this is my little handheld unit. It's got that's a QtPy. That's my little jumper, so I can select the 3 different latitudes, longitudes. That's an Adafruit GPS unit, and it's got the quick connectors on it. It's like a PA 1010 or something, and battery pack. So in the tube is a display with all the readings on it. So I put the tube on it so I could see it outside in the bright sunlight. And so it's kind of the equivalent of a handheld GPS unit. This is my handheld GPS unit. So it
That's a good way to test.
well, yeah, I wanted something that I could just walk out there and say, okay, am I close to the GPS coordinates? And I actually had it taped on a tripod, so I could just move the tripod and look down the tube and see what was going on. Anyway, kind of wondered if anybody else had experienced issues with that, or maybe I'm screwed something up with Arduino, or the IDE, or I've got all the latest, the Adafruit, GPS libraries, the SparkFun libraries. And, it looks like the equations are still working for Dave. Those are the, I sent them an email And, let's see if I can share that again. Oop. Okay, blink. Entire screen. Share. Anyway, that's the email that I sent them, and I said that, for the calculations for azimuth, for some reason we're not producing the correct values, and I told him I checked it out in, it's an IGES map website that actually I showed you wherever it was, that one, that produces the right bearing. And said, I found another program that actually calculates the right value, and he basically sent back and said that these equations are still working fine for him for azimuth, so it's probably something I'm doing, I don't know what, but anyway, so that's kind of where I'm at. And I had some questions about what other more experienced guys like Kareem are doing. As far as, like updates and stuff, do you, if you're not using RTK, do you just like sit still and average a few readings and then don't update it from then on, or do you update it every time you update, the GPS coordinates?
Not sure I followed the question.
I'm just curious how how often you recalculate what your distance to a waypoint and what the bearing is. Do you do that every time every time you read the GPS, every time it updates? Or do you, do it like sitting still, take an average, and then don't take any readings until your platform reaches your destination?
Oh, I see. I've experimented with a couple of different ways. What I typically do is I set for most situations, I set intermediate waypoints about a meter ahead of where the robot currently is. Right.
A meter ahead?
Quite often, yeah. We're talking
Wow.
outdoor navigation, right? And I'm
Yeah.
usually using slightly larger routes. So, so what I'm typically doing, it might be half a meter, it might be a meter, and then I'm just looking to see, whether I've gotten close enough in threshold to that intermediate location, and then I'll do a fresh set of bearing calculations. But I've also done it like on every single loop, and it doesn't seem to matter that much. What the shorter interim, so typically when I'm like explicitly setting a path, I'm only setting the waypoints on the points that I really care about, right? And I don't care as much about what path it follows as it's going towards each of those major waypoints. So, it just calculates, intermediate waypoints just for the purposes of having some sort of a distance-based refresh cycle, if you like.
Okay.
But I don't know. I don't know that my the way I go about it is going to be terribly helpful to you, because I'm using an Android platform, and the way I built it is I leveraged the built-in navigation capabilities, and I basically created a GPS provider inside of Android that took the updated readings and so basically I built an Android service as a separate program that runs independent of the robot itself. but it's constantly getting an updated fix and providing it to the Android system. And then the Android system broadcasts that to any receiving client, anybody who's wanting to listen for GPS updates. And so the robot itself is constantly listening for the GPS updates. So I'm not doing like explicit plumbing or handoffs there. I'm just using the built-in Android system. And Android has pretty good navigation routines as well. So, you know, once I get a location and it's packaged in the sort of the system's API for location, it has functions like get bearing to, right, from current location to some defined next location.
Yeah.
And so that's how I get my bearing calculated for me. So I didn't actually write the code. There's no, I know that it's better than you know, just a spherical approximation. It, you know, takes into account, you know, great circle geometries and that kind of stuff. So, which normally doesn't matter to us on very short distances. Yeah, so I'm just leveraging what's the plumbing that's already there in Android.
Wow. So was that broadcast over Wi-Fi then?
No, this is basically a service. The GPS provider service is it's just broadcasting internally to other clients that have registered with the Android system on that same platform, right? So it's like an IPC call. I don't know what the exact format is. I never had to bother to look it up. You know, you just write a service. In order to create that broadcast, in order to create those location notifications, I do have to do the job of managing the actual GPS module. Drawing a blank on it. It's the F9P is what I'm using, and so I do have to get the correction packets explicitly over the internet from the Wi-Fi connection, and I have to send those to the module, and then I get the updated corrected fix from it.
Wow.
And then I broadcast it to the rest of the Android system.
Okay.
So other apps get updated that way as well. So then I can also do things like look at Google Maps, pull up Google Maps, and I'll get a really accurate fix there at the same time.
Okay. So is that difficult to develop, or has it been years in the making, or?
It took a good chunk of time. I haven't worked on that part of the system for more than a year. Haven't been using it that much. So I would say that I didn't get it to a point where I'd be happy to release it. You know, it's got a lot of missing parts still. And there's some hard coded bits that really should be configurations so that you can, so that it would be more flexible. But there's plenty of examples of code that does this kind of thing out there. So, you know, it's certainly doable. And I'd be happy to, like, I'm not ready to publicly release anything, but, and I'm not really driving in that direction, but if you need to take a look at it, I'm happy to share it with you.
Okay.
I mean, in fact, it's probably an open repo on GitHub, as far as I know.
Oh, there is.
I'm saying my code is probably open. I don't think I bothered to
Hey, Ray,
make it private.
I've been covering some of the same ground that you've been doing. I mean, so my procedure would be to go. Let me share here and kind of go through it. So. Kind of like here's Google Maps of my home. All right, so I would just go in here and make a mark, and then I would go the distance, measure distance, and I'd pick some other point. And I'd try to pick them so I could have, like this, is going to be roughly, it's either going to be 270 in one direction and 90 in the other direction, depending which latitude and longitude you use first.
Mm-hmm.
So, I mean, this was just a test. And I've been able to do really well in getting the distance. Excuse me, not distance, the angle.
Yeah.
But the best I can do on the distance is about 2 to 3 feet. And I'm still screwing around with that. So let me show you what I'm doing here. Okay, so this is just a little, you can, when this thing comes up, just a little, all this is a little C program that's using these three functions. The calculate bearing, okay, and that gives you the bearing. And then this haversine distance, it's a great circle thing. And, it like I say, probably 2 or 3 feet, maybe, I haven't really tried it out at extreme, like 200 yards or something like that to see how much they vary. But it's probably usable in this level. Can you see it?
Mm-hmm.
Okay, so it's probably very similar to the code you're using right now.
Yeah.
And so anyway, I'm just saying that's what I've been messing with. And like I say, angle seems to be easy to get between two GSP GPS coordinates with no problem. And I'm using right now, my strategy is going to be to hook up the GPS unit, the best I got, and an IMU through I2C to Teensy 3.2 and let them screw with that.
Mm-hmm.
Now the actual strategy to do fusion with the two data pieces is probably going to start off really crude, and then eventually, hopefully I can get some better filters in there to get it right. But the intent would be to use past just bearing and distance, and based on the distance from the cone. So like if I say I'm 10 or 12 feet from the cone, then I probably am going to go into a search pattern. So the only thing the GPS
camera
can do
at that point
is to get me down to 12 feet or so. And then I'm going to hoping to use the camera to handle that.
Mm-hmm.
Oh, is Carl on? Carl, by the way, I talked to everybody. I talked to Steve Edwards, and we're officially moving Robo Columbus from October to November. It's the second Saturday of November, which is the 12th. Now, Pat, that shouldn't be a problem for you. You can run early, okay? You know what I mean? But you got to have it by the 12th of November, okay? So, I mean,
I'm not building a snow robot.
You're not building a snow robot, no. So I'm just saying, but for the rest of us, that's going to make it a lot more pleasant. There'll be a lot, probably in the 80s or 90s, maybe, hopefully.
I might be able to join. I was worried that because I got the update from last week's. I watched last week's RBNO and saw that it was on a date that I have where I'm out on vacation. So
yeah, we're moving it back. So November 12th, guys. I'm going to update the website when I do all of this with meetings update. So just wanted everybody to know that.
cool.
But
Oh, Ray and Doug, I got to point out that there's a slightly different use case for
Yeah.
me in that I'm always doing it with RTK or worst case float RTK, which brings, the air up into like, 20 centimeter type of range or something like that. And so I don't have to worry about my current location flitting around. Right. And so if you need to worry about that, then yeah, you need to do something to make sure that you're not taking the immediate reading without sort of somehow cross-checking it, validating it, or averaging it, or something like that.
Well,
if your
there's
robot
a,
spinning off in any direction.
yeah, that's true. And there's a couple of things that I've been thinking about there, Kareem, and I don't know, different levels of sophistication. For example, I have an encoder on my robot. Okay, right now it's only being used for speed, to try to control speed.
Mhm.
It's not really being used to do distance. But if you know your speed and you know the time you're going, you should be able to estimate, or even just do encoder counts and just say, hey, I've moved X, a certain distance away from where I was before.
As long as slippage doesn't happen.
And if the GPS reading doesn't show that, you know what I'm saying? A couple of things. Either you're stuck, which could be a biggie, or you can, that's a bad reading from the GPS. All right, because I don't want the GPS going whoop, whoop, whoop like this,
Yeah.
So what I want to do is just say, okay, the biggest problem I have right now is deciding how I want to make the initial heading. Now I can use the compass, and because by the time we're sitting it down there and getting everything ready to start, the compass will have a reading, and I can use that to adjust my dead reckoning heading. So if my dead head reckoning is always going to be 0, but if you're actually facing south, that'd be 180 degrees. So you just change that reading to 180 degrees, and then that becomes the new heading. And just follow, let that, you can either just say, I'm not going to update, I'm going to let the IMU take care of it because it's better at it than me trying to estimate, or I can update the compass. Well, now, as soon as you've got a true direction, you really know which way you're going, then you can to make a better estimate of like, okay, it says I've moved 50 feet and it says I was going at this direction. And if I look at what my compass GPS is saying, no, you're gone, you got this direction, you got to go off this way. I should be able to know whether I'm really way off. Now, like I say, a Kalman filter is the right way to do this, but I'm still having trouble wrapping my head around it. So, I'm going to do all of these little dinky things to try to get close enough. But anyway, so if you come across the routine that matches Google's value, I've run across several that they say, yes, this definitely is the same thing you get out of Google. But about the best I've done is about 2 feet. Out of 75, it's about 2 feet off. So the GPS is probably more than 2 feet off. That's probably good enough anyway.
So you're saying you're going to say it's bocce ball and grenades if it's 12 feet away?
Well, I'm thinking
that's your target circle.
Well, I'm hoping, this is, we got when it's in my backyard, if at 12 feet it can't find a cone, then I'm going to have to change my thoughts about it. But from what I've observed from other people's robots, at 12 feet, they almost always lock in. Even, they might have to do some sort of little routine to get pointed in the right direction. but once they're 12 feet within the circle, they usually can find it. Just
Good
this,
fight
just,
code with the camera.
yeah. So that's what I'm really trying to do. So what'll happen is someplace it goes into this secondary strategy of how to find a cone. Now, once it gets and hopefully touches the cone and stops, then it has to back up some distance. Okay, now at that point you put in the new waypoint, and you have to you make sure probably we need to check that your heading is right again, and then off you go. Hopefully, in theory, but
Mhm.
you know I want to at least get my mug this year. So so
Well,
anyway, that's I've been playing with that. You know, I still have the autopilot base going, and that one, you know, in theory should have done that. All right, but I had a real hard time with what they call MavLink. That's how it communicates. The autopilot communicates with the Mega.
mhm.
And one of the things they have is message is distance to waypoint. And for some reason, I could never get that to be really good. And, you know, it would fire prematurely. So what would happen is I'd end up going into a cone search way far away from my target.
Yeah.
And I'm trying to figure out, you know, like I say, I'm hoping to kind of parallel both of those tracks and we'll see which one pans out. So
Kind of reminds me of the Monty Python thing, you know, the French throwing insults at the English. I fart in your general direction. You know, that's what
yeah,
GPS is.
yeah, well, like I say, I got to admit that I'm really impressed with the Nine's ability to pick up satellites, and at least in a stationary position inside a house, it is better than the 8 was ever been.
Yeah.
So,
Yep.
so I mean, it is an improvement. You know, whether it will do anything better outside, it's hard to say. I mean, it
Yeah.
should, but you know, I don't know how susceptible it is. But I mean, it's amazing to see how many satellites it picks up. But you know, I can watch you know, where every reading it takes, it just maps it on and so you can watch how it's going. And
Yeah.
the blob is really pretty centered. So it is an improvement.
Yep. Hey, Paul, did you actually buy those two, the Ardu mower GPS units, a base and a rover, or no? Okay. Their price is much better than SparkFun. You know, it includes it looks like an XB or a Zigbee. I can't remember which, for the radio link between the two. The higher end, the dual band antenna. You could probably save at least a couple $100, if not more, buying that unit than the SparkFun unit. So SparkFun's gotten pretty pricey.
Yeah. Well,
And
you
it's
know, it's
based on
really
the same module.
Is it a U-Blox F9P in the Ardumoa device?
I think it is, yeah. I can look it up, but I thought it was. So, and you can buy it as a package all set up, you know, rover and base, and kind of like for a lot less than
how much
SparkFun.
less,
And
Ray?
SparkFun doesn't seem to have what?
How much less, Ray? Are we
How much less?
talking?
I don't know.
You know, like $600 opposed to
$200
$800,
less.
or
I see the
It's probably like
Ardu. I assume you're talking about the Ardu Simple AS RTK2B F9P GPS development tools.
Yeah.
Is that? And it's
I think so,
219, 215 at Mauser.
Oh, it's 215 at Mauser. Man, that's
Yeah.
cheap.
I think I'm trying to remember what I paid at Spark Fund. I got a feeling it was in the like 280 range.
Yeah, but that didn't include the cost of the antenna, right? And it didn't come with a radio link.
That's correct. It does not include the radio or the antenna. Yeah, the
Yeah.
Spark Fund. Um, uh, let's see, GPS RTK SMA breakout, which is what I've got, is 274 at Spark Fund. So I guess there's about a $60. The Argumower is about $60 less, and you said it includes the radio.
Yeah, if you get the base rover kit, it includes the radio. I want to say it was like, around 530 something, but don't quote me on that. I'd have to look it up again.
Yeah. I I I would not. I know that the Ardu Simple, I think the Argumower includes a base station and a rover, and I'm not using uh, the base station. I'm pulling corrections off the web. So I only had to shell out the
Okay.
285 or 275 for one rover unit. I say only, not really only, but
Yeah, I'd have to look it up. It seemed like if that was the package price, it's a lot less than what you could get it for at Spark Fun. But I can look
thanks
it
for
up.
the
It's there.
info.
It's a different module.
Yeah, I've got it now and hope it's going to like not break. So Ray,
Yeah, I'm not looking at the
a
right website.
question about your wrong azimuth to the waypoint issue.
Yeah.
And you've got one algorithm that works, and then David's algorithm doesn't work. Just a thought: you might assume that they're both taking in the same inputs. So you might work through both of them, even with a hand example, by hand, and see where if they differ, when you compute it by hand, because it sounds like
Yeah.
if they're taking the same input and one gives the right azimuth and one doesn't, it sounds like they're, X and Y are mixed up somewhere, or
Yeah. I've checked the formula several times. They're identical to what Dave used. Apparently it still works for Dave. It's the weirdest thing. I am using, two different processors, two different GPS units. The Adafruit one gives it out in degrees and decimal minutes. So you've got to convert it to decimal degrees. The SparkFun unit actually sends it out as a long, and then you divide it by I think it's 1 and 7 zeros or 8 zeros to get it, to move the decimal point to the right location.
so the inputs aren't the same actually for the two algorithms.
Well, you can, you have to make them the same. They all have to be in decimal degrees.
Yeah, I know. It's just a thought.
Yeah. I even, wrote a couple programs that just did the calculation without a unit attached, providing, 3 sets of, kind of like the current or the starting GPS coordinates and then ending GPS coordinates, and they match what that website, the IGIS-Map website, that shows my little piece of property with the dot, 2 pins on it and the correct angles. So I don't know what's going on. It's
I didn't,
bizarre.
I didn't hear you characterize how far off the results you're getting are from David's algorithm.
Okay, like for the first set, David's algorithm said 58 degrees. The other algorithm in the IGIS website said 129 degrees. So it's not like it's 180 degrees off or something. Okay, David's algorithm said 102. The calculation was actually 80.3. And then David said 154. And the other algorithm said 30.96. So it's...
What kind of distances were you typically giving for the current location versus destination?
Let's see.
How far apart were your waypoints?
The smallest one was 4.91 and the longest was 7.29 meters.
Oh. And then you're doing that with artificial data, you're getting that variance, or when you're getting real location? Because the amount of error that you can have in your current location can be pretty wide if you're doing it live, right?
Yeah.
With those short distances, right? So if you made it 100 miles as your distance, is it still accurate? Does the accuracy improve is what my question is.
Oh yeah, I'm assuming it may.
But the battery runs down.
Yeah, I don't think my battery would last 100 miles. Definitely not.
Yeah, just to see if the error goes away.
Oh yeah. I see what you're saying. Yeah, I could do that. Try, a distance quite a ways away, just pick different GPS points and see if, maybe they converge. But with
But yeah, if you're putting in just, not real data, but known locations, they should not vary like that. Yeah.
No, I wouldn't think so. But yeah, and it actually looked like it was able to get to 2 of the 3 waypoints. It started circling where it thought the one waypoint was, and I'm assuming that maybe I'm not turning fast enough to get to where it wants to be.
Mm-hmm.
So, but I've only got the threshold set at 1 meter now, so I could go out to maybe 2 meters.
That's a pretty low threshold if your error is as big as you're saying it is.
Yeah. Yep. Yeah. So I don't know. It like I said, the other algorithm that I used, not David's, to figure out what the bearing was, matched, what the IGIS website said it was, or said it should be. And so, with our numbers, I wouldn't think I should get any variance. The numbers are what the numbers are, and either it calculates it correctly or it doesn't. So, and right now that
hard-coded locations vary.
Yeah, I just went out and wrote them down, and then put them on the map, and they're at least where they could be, in the general location of where they should be. So, and as far as like the stability, I think they said 4 digits or 4 decimal places after the decimal point corresponds to like 185 millimeters or 7.3 inches. And then if you go to
That
like the
can't be
fifth,
right.
um,
That doesn't sound right to me. I'm just going off of memory here, and I'm not actually looking at the calculations, but
yeah,
decimal lat long. I seem to remember needing to go out to like 7 decimal places
maybe
before it started.
for the
Maybe for the
F9s,
RTK,
but
maybe. All
when
right.
you're getting down to, on the smartphone site, he details, what each decimal point, should indicate. So yeah, he says, let's see, where is that?
We post a link to that would be good.
Okay. Yeah. I'm assuming his calculations are right. He seems to know an awful lot about GPS stuff.
Wiki.gis.com shows 4 decimal places as 11.1 meters at the equator.
That sounds a lot more
Okay,
reasonable to me.
Okay, hold on a second. I'll show you. And, just because it's on the smartphone website, I mean, it's got. Yeah. Okay. 8. Got slow.
And Pat, you could share that link too.
I've got some issue overloading and slow network.
Yeah, my a quick calculation shows that 1 foot would be 1/300,000th of a degree. So just backing up what Kareem is saying, that you ought to be in 6 decimal places.
I'm losing you guys. Can you guys hear me?
No.
No?
Off and on, you
Okay.
freeze quite a bit.
Okay. I think I'm finally back here. I'm asking my little network to do too much. Let me see if I can find it. It was an issue loading this feed. Refresh feed.
So 6 decimal places would show approximately 111 millimeters, which is just around the 4-inch mark.
Yeah.
Or plus or minus 2 inches.
That matches my calculation.
Which is interesting because
it doesn't look like I can get to it right now. Let's see.
Yeah, when I'm getting a good RTK fix and the robot's sitting still, the first 6 digits aren't changing at all. And quite often the seventh digit isn't changing.
Yeah. But those F9s are good for like what, a centimeter?
Yeah, centimeter or two. Again,
Yep.
pretty good.
Okay, I'm almost there. I can show you where
Doug's got his robot moving.
Aha.
Dodson.
Yeah, I was just testing to see if the battery was still there.
Nice.
Does that qualify for a gold star?
I don't
I'm
know.
planning on it. I'm next after Ray.
Hey, Doug, can I
Yeah.
jump in for just a second? Because I got to go pick up my wife at not
Yeah.
my wife, my
Yeah.
daughter at the airport. So
Go
I'm going
ahead.
to have to bug out. So you mind if I
sneak in
just,
the-
it'll just be real short.
Okay.
Sure. Anyway, can you guys see that
No.
stuff here?
No, I just see an R. I don't see any screen.
Oh. Huh.
There
it
you
is.
go.
Get the website up now.
Okay. So this is where I got that as far as like the fourth digit, 0.1 minutes.
Yeah, put the URL in the chat.
Okay. Okay, I'll do that in a second. Not unless I interpret this wrong, but degrees, minutes. Okay. Yeah, so here he's saying, fourth digit over, 0.0001 minute is like 185 millimeters. And then the next one down, it's, you just shift it one over.
Well, yeah,
see-
that's right. But you were talking degrees before, as I understood it. Maybe
Right. You were talking decimals.
Oh, yeah. I guess his thing does list 1 degree, 60 minutes.
Yeah.
so. Doug Parody
Yeah.
was asking if he could butt in because he's got a.
Sure.
I gotta
Yep.
bug out.
Go
airport.
ahead. Go
All
ahead.
right, guys, I just wanted to make people aware of the potential opportunity. I came across this and I was wondering if anybody would be interested in doing a group buy on this. This is a 6-volt, 20 millimeter motor with encoder by a company that's pretty good, and they've essentially not making them anymore, and they're selling these for $5 a pop. Now, what's really cool is if you buy $50 worth, so what's that? I guess that's 10. They don't charge shipping, so it really is $5. So anyway, I'll put the link in, and if anybody is interested in doing that, send me an email and how many you're interested in, and we can work out something. Okay. That's all.
What's the speed on them?
150. Okay. Give me a second. I'll go back to. Too many
Yeah, I
windows.
think the torque is what I was interested in. How strong were they?
Yeah. Okay. Here is the spec. All right. So if I can get this into the chat, I'll put both of these links, okay? And you can look at this. This is the motor, and it's got all of the. So you can look at. Let's see where its stall is 0.4 newtons per meter, which you would never want to do, but you want to be running in this area right here. So there you go, and that's about 78 RPM. The max on the no load is 150 RPM. Okay.
That seems like a pretty good
For
speed.
$5, you can't even get it with a like I say, a quality motor with an encoder for $5 is a steal. I don't
So
even think
you're
so.
calling them a quality motor that you would put in your outdoor robot.
Well, I happen to have two of them that was given to me a long time ago, and that's how I was trying. I had these two motors that was given to me by an ex-member named Rick Swan. So I was looking them up because saying, well, I wonder what the specs on these are. That's when I came across this. Okay. So when I found the specs for the motor, then I looked at it, and I actually have two little physical ones in my hand. They're equivalent to a polo loop, probably.
So you're going to come to my presentation for Seattle
sorry?
group later this month.
I'm
I'll
sorry.
slip you a $50. You get me 10 of them. Anybody else will ride for free.
Oh, well, if you're going to buy 10 of them yourself, I'll give you the links, and you can just go ahead and buy them and get them mailed to you.
Well, I thought you were going to get several other people to get
Well,
in.
I'm gonna say we can,
Yeah.
if we can, that's great. I mean, I
I was
don't care
hoping-
either way.
I
Either
was
way,
hoping 10
uh,
because I could use them.
yeah. Give me let me see. Let me get this into the links, and then I'm gonna stop sharing and see if I can get this in chat.
While Doug's doing that, I'm just covering voice in here. I gotta get back to work things, but I think Doug D is probably also needs to sneak in there, Ray, a little bit because his battery's just waiting to present.
That's fine. I'm pretty much done.
Okay.
So
Okay, so y'all have probably spotted this robot behind me here. I've been moving it up and back to make sure it's still alive. I'm going to present my screen for just a minute. And you should see my pretty much standard Tkinter front end for it. It's showing the video driving thing, and I've wired up a bunch of these things. Y'all have seen these before. I can click on forward, stop it, click on back, stop it, and stop sharing. And now, if you pin my screen to get a bigger view, you can, I'll show it from the camera's point of view. Let's see, forward. You can see it back there running around. There's my gold star event. I am done with this.
Yay, gold star.
I'm getting ready for
it's
my
very
presentation.
quiet too.
Yeah, it's not as noisy as it used to be. It doesn't seem like. I still have to put the head and arms on, and I've got to put the hole or the PVC pipe to stick the selfie stick in, so I can put the phone on it. But I think it's going to be functional in time for my speech. The object avoidance things are not working at all right now.
Before it left
it's
all
private.
the nylon shavings from the gears on the garage floor.
Yeah. So I just wanted to show that I had it running again, and yay, the battery lasted. I've got my little battery in it right now, and it's not fresh because I've been using it. Oh, I guess I could pick it up. This is it right now. That's the hole. I've got the Raspberry Pis inside here. The Arduino is underneath, and I can't show you because it's inside right now. I've got my power distribution board there, all working and everything. And I just got to put the head and arms on and put the sticks up here for the iPhone. And I've tested my Skype connection. That works. I think I'm pretty well along the road here. I'm pretty happy with it.
Good job.
So that's all I had. I'm going to power down. Turn off my little switch in the back. Who's next?
Okay, well, I don't know if did we finish up with Ray, because we discovered that he was talking about 4 decimal points in minutes, and it seemed like he's got 4 decimal points but using degrees. So is that
Yeah.
the issue?
Yeah, I think that's what it was. I didn't realize that was in minutes, not degrees.
All right, the stump the brains
So-
trust came through again.
After I get done with my thing for Seattle, I've got this little B-Tree-in thing that is a IMU that there's an article on the DroneBot workshop about how he uses that. He built a little hand carried thing, so he carried around and he got GPS with like a whole bunch of different satellites and stuff. So I want to see how accurate that will be, but I need to finish this other thing first. So I'm happy to keep listening to what you guys are going through. I won't have to solve those problems. I can just say, oh yeah, Ray talked about that.
That's right. Yeah, I don't think Kareem, were you the only one who was using RTK in the last outdoor contest? I don't think Scott or
have no
anybody else
idea
was
who-
using it.
I have no idea what
What?
others were using.
Oh yeah, I guess it's not obvious. I'd have to have a base station out there, but
I didn't have to have a base station. There was a RTK to go broadcaster up in that area, not really far
Right.
away at all.
Yeah.
They're gone now. So, yeah, we would have to probably set up a base station.
yeah, I guess it wouldn't be obvious if you didn't have a base station sitting there. So
Yeah.
who knows what you were up to?
Secret stuff.
Yep. But as far as I know, no one else was using RTK.
Yeah, probably not.
Yeah.
It didn't turn out to help me. You know, if you got a badly tuned drive system, regardless, it's not going to help you out.
That's true.
Michael had a robot he was playing with earlier. If y'all are done,
I'll just add to that, and then I'll release is that I can testify that when you're trying to control an excavator with RTK, the problem is not so much the RTK precision, it's the precision of controlling indirectly through hydraulic levers, you know.
And linear
How many
actuators. Right?
degrees of indirection? I'm trying to control motors that move a joystick, that move a hydraulic lever, that then controls just a relative flow through the hydraulic motors, and there's no feedback. So that becomes a bit of a challenge in and of itself. I do have feedback from the IMU, and I have feedback from GPS telling me where it's going, but I don't actually have any encoders on the tracks or anything like that. So, you know.
Yep.
Yeah.
I thought for sure we'd see a video of the thing going on, you know, some highway somewhere, you know, just out of control. You know.
On the news. On the 6 o'clock news.
That's right. Running over the family vehicle, you know, getting into the living room, you know.
A runaway excavator would be a cool segment on the news. Absolutely.
Yeah. Yeah.
that tops the chest robot breaking somebody's hand.
Mm.
Somebody else gonna go?
I got something I want to show. I think I showed this here a while back. This is a look at this whole thing. Yeah,
Isn't that similar to what you have, Doug? Maybe.
I think that is a similar one. That Radio Shack Roby Jr.
no, I 3D printed this. No, I didn't. But
Okay, cool.
this is my wife collects and sells antiques, and she gave me this. It's a Tomy Tomy. It's not Radio Shack.
Yeah,
I
tell
looked
me
up-
about the Radio Shack stuff.
Tomy. No, I can't see that.
Yeah,
Tomy. But anyway,
Yeah.
yeah,
I
tell me
looked
the
it up.
Japanese company.
Apparently, it had a remote because there's an antenna,
Yeah,
and it's called a chat bot. If you look, it looks like a cassette.
see those arms that similar arms to what you got. It looks like.
So, I looked this up, and you get eBay for about $35. This was made around 1985. So,
Yeah.
okay, I was thinking about. I don't know if I want to butcher it or not, but I was thinking about modifying this sucker for the 4-can or the 5-can competition. I think it might be able to do it.
I think
But
you
being
should.
an antique, I don't know if I want to tear it up or not. If I
Yeah.
don't, I could gut this thing and make something work, I think. But if I don't, I could like take everything and 3D print a copy of it, reasonable. I think it's kind of a cool little deal. It'd be kind of a novelty during a competition. So that's all I wanted to show. I also,
make a Godzilla skin for it,
yeah, that too. That'd be pretty cool. Anyway, that'd be something I might try to modify and put an Arduino in it or something. But see, it's got a little caster on there. It's got a caster and 3 wheel. I don't know how they look like these. I don't know how they turned them, how they would stop. Maybe they got a clutch in there that releases 1 wheel or something. I don't know, but when you turn them manually, they go. I haven't went inside yet, but maybe they had a clutch in there that would stop 1 wheel or release 1 wheel. That way it can turn. They apparently seem to be on the same.
When you hand turn it, does that turn both of them?
Yeah, it turns both wheels, and if you try to put some resistance on the other one, it won't turn. So
Yeah, 'cause it's different from mine.
same gearbox somehow. But my question is, how did they turn it like that unless they got some kind of clutch thing in there or something? Please. I haven't tore it apart and looked at it yet. Also, I'm thinking about, just in passing, on I've messed as far as CAD programs I've messed with, and I'm not an expert by any means. I'm just curious, and I fool those stuff with stuff. FreeCAD, Fusion 360, and design. What is it? Design Spark Mechanical. I've messed with all 3 of them, and I'm thinking about getting into some Onshape and try some Onshape because it's a web-based CAD program, and I run both Linux and I run Windows, both depending on what's going on. So that Onshape will run in a web, doesn't matter what operating system you're using. Has anybody ever tried Onshape for a CAD program?
Nope.
Well, I'm going to give it a shot. I'm going to let you know and maybe compare it to like 360, Fusion 360 or something. Just
A lot of the teams in the high school competition that I teach or that my team is in. There's a lot of teams who have moved to Onshape.
Well, I think it's pretty cool. I've been using FreeCAD for a while, but being an open source kind of a hobby type of CAD, it's to get support for it, it's just got to go to the forums and stuff. And
Yeah.
and this Onshape looks real professional, like a Fusion 360. So I'm going to give it a shot. It looks like they got a lot to offer as far as backing up your stuff. So they use it a lot in the high schools now and stuff, huh?
Yeah, it's they make it free. They're all fighting over future consumers of the product, so they make it free to high schoolers and sometimes to college. So Fusion 360 is free. All of the Autodesk products are free also to them, and we're still using Fusion 360 because of the CAM stuff that's built into it, and we do a fair amount of that. So we have it over.
Well, I like Fusion 360, but I like playing with Linux, and they don't, they won't do a Linux version of that. So
Right.
I switched to FreeCAD. But this Onshape is actually free to hobbyists too. So that's pretty cool. That's why I'm going to check it out. And it has that save, where you back up every step, like Fusion 360 will
Parametric.
will give you can go back a few changes. Well, this Onshape apparently does the same thing. So I'm going to give it a shot. That's all I got to say.
A quick update. I looked up that robot. It's a Tomy chatbot.
Yeah. Chatbot.
What
I
if
don't know
that's
how it works. It's got a recorder. Got some stuff here going on. It's got a little lever on the side. I don't know what all that's about, but
chatbot? It's Chatty Cathy, maybe.
yeah. I'm fixing to make a five candle. Or maybe just a four corner bot. I don't know if I should be tearing this thing up, being an antique like it is. But it ain't like it's it ain't like $400 on eBay. It's $35.
Yeah.
Apparently they're not that big a deal.
It's not that antique either. It's only 1980.
Yeah, well.
I remember seeing commercials on those, and there's one on YouTube, and I just posted it.
Oh, cool.
Michael, if your wife's prone to sticking things on, whatever eBay, you might want to hide it for a while,
She's the one that gave it to me.
Oh, she did. Okay, you're safe then.
She doesn't do eBay anymore. They got into all that taxes and all that stuff, so she got away from that. So she just sells at these, at a booth at this antique mall in Mansfield.
Oh,
And
okay.
so she's got a couple of booths there, but she's really into that antique stuff. I call it junk. She calls it antique because I'm always looking for the new shiny thing, not the old wore out thing. So
Just as long as she doesn't put a price tag on you, because we're getting up there in age. So
I'm gonna look at that. Where's that at? Let's see. YouTube. Okay, cool.
you're in trouble when she ties a price tag on you.
Oh, it's pretty cool. I've seen a little bit of that. I wonder if somebody's got one running today.
Maybe it sounds like Stephen Hawking's used to sound like,
So anyway, I'm done with my little deal.
If nobody's in queue, I've got something.
Go ahead.
So last week I showed y'all that I had acquired a second robomower. So that one I'm pointing at there is the old one that I've been using for many years, 10 years or so. One behind me is the one most recently acquired, although it's actually a slightly older model than it's like previous rev of the one I've been using for a long time, but still works the same. And so this last week I got the wiring into the robot to feed the encoders back out to my electronics box in the back there, and tested it out. And so now I can I'm going to run a script that tells it to move a half meter, rotate, and then move another half meter. And the dog will probably get run down, but she'll move.
Casualty of demo.
Oops. Oops. That didn't work too well.
Yeah, don't leave burn marks in your carpet.
Oops. That didn't work. Huh.
The god of the demo smites thee.
He did. It's like, wow, what happened to that? It was working earlier on today.
Yeah, it worked at home.
It's a bit embarrassing. Also got a Xbox controller that can drive it, but that's very confusing. Oh, so what I was doing earlier today was I was doing the moves one at a time.
What is it saying?
Well, when the bumpers hit, it goes boing. So it's running into the bookcase, and the bumpers are going boing. But
Boinging away.
how frustrating. Did I forget to hook up the here's the problem. I forgot to
Encoders?
plug in the encoders. excuse me one moment. Okay, once more with feeling. Back this baby up. Put it into bit mode. Okay, now. Yeah, I had the electronics box out and in the old robot just to prove their equivalence, and it worked fine. And then when I put it back in the new robot, I failed to Okay, that was a request to move 0.5 meters, and then request to rotate 90 and then move another 0.5 meters. It's using a compass for rotation. There we go. So, I mean, no new functionality there. You all have seen this before, but the new thing is that it's in a new robot with the electronics just like dropped into the new robot. 3 wires to add the encoders and one other thing to make the new robot function equivalent to the old robot. So that's my gold star effort. Thank you. And I guess I got one other thing just unrelated to that, but that's kind of fun. I'm going to share my desk top. Hopefully, so this is really for Ray. Ray, have you seen this Deep South Robotics self-driving mower with a Skag mower?
Not with the Skag mower. No, is that new?
It's not real new, as far as I know, but the guy mows a runway with it. And look at that! Isn't that awesome?
Yep.
You know, last week we were talking about Aju mower and open mower, which are like 6-inch wide mow width.
Yep.
But this is a real mower. This is what you need for your ranch out there.
Yeah. I almost bought a zero turn this year, but you know, the old mower's still working, so.
Yeah. Anyway, I just thought that was pretty fun and something
Yeah, they're easy to control. It, you know,
What's
basically a linear actuator and well, in that case, probably just 2 servos because it has independent you know, transaxles on each wheel. So,
Yeah, right. He got a so apparently the levers that you use on those zero radius mowers, they apparently hook up to a disc and rotate the disc that causes the clutch to go into forwards or reverse at different speeds. So he hooked a lever to a servo to operate that. Anyway,
yep. Yeah, it's
cool
like a variable displacement pump.
Yeah.
And the lever basically controls, it's like I think they used to call them swash plates. It controls how much the pump pumps and which direction it pumps, and depending on which way the plate is pushed against the, there's like 4 pistons that rotate in the pump. And
Okay.
Yeah, so
anyway, I like your big mower. I like big mowers, and I like your big mower. But this is a really big mower. Autonomous.
Yeah. You like big mowers, and you cannot lie. No.
That was all I had.
Yeah, that's kind of the next step up. The differential that I bought, I can control it. Well, one of the things I haven't done yet that I've been wanting to do is put a brake on each side. So then, if you break one wheel, the differential will still rotate the other wheel, and you can use it to turn with. So instead of having like a linear actuator for steering, you can just have 2 brakes.
Hmm.
on either side and the back, and you can, use it to steer that way. But only you can only go forward or backwards. You can't put one forward and the other backwards.
All right.
Both
Right.
have to go, forward or
Yeah.
backward. But
Can you set them to different speeds?
say that
Right.
again.
Can you set the two motors to different speeds? Or are they tied together?
Well, well, mine doesn't have two different speeds, but I can, like, for a moment break one wheel and stop it from rotating,
So it's
and the
one
other
motor.
side will rotate. So it's kind of a, how long and how hard you're applying the brake, because your brake can still let that one wheel move a little bit. So but if you lock it up, it's kind of like a skid steer. When you're not driving both sides, you're just pushing one side or the other side. But I have the brakes, I just haven't put them on yet. So they're pretty good size. So this is the braking mechanism here. There's a little lever that actually squeezes two pads together, and that basically, stops that rotor, and the rotor's keyed to the axle. And so, I'd have one of these on each side, and then a servo to actuate that lever, to pulling it up stops it, and pushing it down, allows it to slide. So these are actually go-kart parts. But
Got anybody else stepping up?
nope.
I've said all I've got to say.
Actually, well, I have a little kind of a war story related to Ray's 4 decimal points of precision on minutes.
Yep.
So on a project I worked on, we used ROS, and anyone who's used ROS has used RViz as the visualization tool to show where the robot was. And we found that, and the coordinate system for the robot was set at the equator, and it used UTM as coordinate points. So being where we were up in Colorado, the UTM distance from the distance from the equator was 4 million something meters, 4,800,000 meters or so. And so RBiz is based on a graphics engine that uses 32-bit floats. And so what we'd find is that the when the coordinates of, for example, paths came in relative to the equator, that was 4 million meters away, we could see jaggies in the path because we were zoomed in to, like, look at just a few meters, and the least significant decimal point of, so that was the 24th bit of the mantissa, was jumping, and we could see it on RViz because RViz's origin was, so far away, and it only dealt with 32-bit floats. So that was kind of a interesting war story that that your 4 digits of precision reminded me of.
Yeah, I didn't realize that was minutes. I thought it was decimal degrees. So I guess it was one 1/60th of a.
Yeah, but seeing jaggies in the path on RBs, and we're like, why is that? Well, we're looking at the least significant bit of a 32-bit float changing. It's
Yep.
like, whoa, okay.
Welcome, Harold. I think we've just kind of run dry this evening. Did you
I
have
was
any stories,
hanging
Harold?
out with a bunch of 3D printers, 3D printer guys, and that kind of stuff. I figured I'd just drop in and see, you know, what the cool kids were doing.
Well, not that you're scaring us away, but I suspect that we're all kind of run dry. So
Okay.
Oh, that was one other thing I did look at, like the size of floats and doubles in Arduino land. They used to be the same. It was only 4 bits used to represent a float or a double. But I did the size of with the ESP32 and the Cutie Pie, and it came out as 8 bits. So I thought that was good. At least the doubles are,
I hope you mean
represented with
bytes,
more
not
bytes
bits.
than a float. What's that?
I hope you mean bytes and not bits, because a 4-bit float would be funny.
Oh, okay. Yeah, sorry, bytes. But
Hey,
yeah,
Capital B, lowercase b, you know, whatever.
yeah. Gotcha.
Okay, well,
all right, guys. Yeah.
it's been fun.
All right. Well, next Tuesday night, have a good week. Good luck with robots. 2 gold stars tonight. Well done. Catch you later.
I guess.
Okay, guys.
Night.